Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we are here today to continue analysis of indeterminate structure using flexibility method. Okay, this one I have actually chosen one beam question. We are going to analyze by considering support settlement. Okay, by looking at this beam, so this beam has A is fixed, D is roller. So by looking at the support, there are four unknown reaction. And always remember that we can only analyze three using equilibrium equation. Okay, when we analyze determinate structure previously last semester, we analyze or we calculate reaction using three equilibrium equation when in the system has three unknown reaction due to support. But this time, this is indeterminate beam. So this one has four unknown reaction, and four cannot be determined using equilibrium equation only. So that is why we have to apply flexibility method. And there are okay, we have to find the difference. We have to find the difference between four unknown reaction and three equilibrium equation, three reaction that can be solved using equilibrium equation. So that is why we get one redundant in the system. This is redundant. So this is redundant. What does it mean? We can only calculate three using equilibrium equation only after we determine redundant, because now redundant is the problem. If we have the redundant value, we should be able to determine remaining unknown reaction, three remaining unknown reaction using three equilibrium equation. Total moment is equal to 0, total Fx is equal to 0, total Fy is equal to 0. That is the idea, that is the concept of flexibility method. So basically, this is the degree of indeterminacy. And degree of indeterminacy is actually representing number of redundant in the system. Okay, this question, okay, we need to consider support settlement at support D of magnitude 25 mm. And always remember, support settlement occur in actual system. Support settlement occur in actual system. Delta D is equal to negative 0.025 meter. Okay. Support settlement occur in actual system. Support settlement occur in actual system. Okay. Always remember that we will determine the redundant using compatibility equation, which is based on displacement at redundant position. So in this case, we will choose, okay, always remember redundant will be removed. Redundant will be removed from the system. So we have already determined one redundant, and let's say we want to choose dy as redundant. Normally we can solve this problem whenever we have the same position of redundant, and the same the settlement is also occur at same position. Okay, so what we need to do now is we have to choose dy as redundant. So when settlement is given at position D, it is best to choose dy as redundant. Okay, choose dy as the redundant. Choose dy as the redundant. Choose dy as the redundant means that we have to remove dy. And after choosing dy as redundant, at this level, you should be able to write the compatibility equation. So using principle of superposition, we will write the compatibility equation based on the principle of superposition. Okay, and the general equation, okay, we will write the compatibility equation. The compatibility equation, and this is also known as flexibility equation. Okay, and this compatibility equation is actually based on displacement occur at redundant position. So we will base on the general equation. So from general equation, okay, it is actual beam equal to primary beam plus redundant dy applied, or we can start with the primary system, means displacement in primary system. So it is primary beam plus redundant beam, and we call redundant beam, we name the redundant beam, it is redundant dy. Applied means we will apply a unit value of redundant in redundant beam. We will apply a unit value of redundant in redundant beam. So these two systems are the determinate system. Okay, combination of this become original, means actual system, actual beam. Actual beam is the beam, okay, that is given in the question. That is actual. So displacement, we have to look at the displacement, vertical displacement or deflection that is occur at D, since dy is force. Always remember that when we want to calculate rotation, we have to look at the moment. When we want to calculate delta, we have to look at P and delta, M with theta. So now dy is P. So that is why we have to find deflection at redundant position. So from this, we will write the formula. No, not the formula, the equation. So it is delta D naught, or we can also change D to numbering. Because D is the redundant, so we can have R1. We declare dy as redundant number 1, because this is one redundant system, so this is dy. So now we are going to use 1 as the symbol, replacing D. Okay, replacing D. So we have delta. Okay, we use the standard label, 1 for redundant number 1, 1 note. Note is always symbol for redundant. Okay, plus with redundant system. F is flexibility coefficient. It is deflection if in primary system we have to calculate deflection. F will be rotation if in redundant, in primary system it is theta, it is rotation. Okay, now it is F. Okay, it is F. Okay, F 1 1. Okay, 1 note and 1 1. Okay, we have to times with redundant. Redundant is dy. So it's best to put the dy instead of put R1, we put dy here. Okay, and this one is equal to the settlement. Without settlement, this equation is equal to 0. Without settlement, this equation is equal to 0. With support settlement, this equation is equal to settlement given. Settlement given. As long as deflection and forces occur in same direction. dy in vertical direction, support settlement also in vertical direction. So it is equal to negative 0.025 meter. 0.025 meter. That is how we include support settlement into the compatibility equation. So from this compatibility equation, so this is actually the compatibility equation. Okay, this is actually the compatibility equation, but we need to determine delta 1 node and F11. This is the compatibility equation. Okay, so our task now is we have to analyze two systems. We have to analyze two systems. One is primary system, one is redundant system. One is primary system, one is redundant system. So we have to analyze two determinate system because okay, by looking at the symbol here, we use one node and F11. Okay, actually we can also put as delta D naught plus FDD. dy, doesn't matter. You can choose either one. Okay, means that the first notation used here, the first notation refers to the position. It is deflection at position D. It is deflection at position D. The first notation, this one, the first notation is for the position. And the second notation is for type of beam. So by looking at the delta D naught, we know that this is displacement at position D for primary beam. That is the physical meaning. Of this. Physical meaning of delta D naught is deflection. It is a deflection delta D naught. Okay, wait. Okay, this delta D naught or delta 1 naught, we use symbol 1, right? Okay, what is delta 1 naught? Delta 1 naught is deflection or vertical displacement. Is vertical displacement at position. The first notation is for the position at position D. Because R1 is equal to dy at position D. Delta 1 naught is vertical displacement at position D for primary beam. Continue this for primary beam. Okay, for primary beam. This is delta 1 naught or delta D naught. Okay, delta 1 naught or delta D naught. And we have another symbol, another deflection symbol. It is F11 or FDD. So F11 is so this is F11. F11 is vertical. It is the same. Vertical displacement due to a unit value of dy. Due to a unit value of dy, okay, due to a unit value of dy at position D, at position D for position D for redundant beam. So that is actually the definition. We call it as physical meaning. Physical meaning of delta 1 naught or delta D naught. So it is a vertical displacement at position B for primary beam, and F11 is F because of this statement. It is F because of this statement. Okay, it become F. It is delta without the statement. Okay, it is delta without the statement. Okay, F11 is vertical displacement due to a unit value of dy at position D. Okay, the first notation is for the position. The second notation is for type of beam for redundant beam. This is redundant beam. So there are two displacement. One is in primary beam. The first determinate beam that we are going to analyze, and the second one is redundant beam. The second determinate beam that we are going to analyze. So we have two beam. We have two. Okay, like this, we have A, B, C, D, 60, 60 and 100, 3, 3, 3. Okay, we remove D, Y, so it become cantilever. When we remove dy, it become cantilever. Okay? When we remove dy, it become cantilever. So we have, okay, it is cantilever. It is cantilever, point load, hit one, and another one, point load. There is no roller anymore because we have removed it. Okay, it is 60 and 100. This is 60, this is 100 kilonewton, and length is 3 meter, 3 meter, 3 meter. Okay, so this is primary beam. So this is primary beam. So this one is primary beam. Okay, primary beam. And we have another one. Same type of beam. It must be cantilever beam as well. Okay, so for redundant beam, if primary beam is cantilever, redundant also cantilever. If primary beam is simply supported beam, redundant also simply supported beam. Okay, it differs due to loading only. Okay, so for the second diagram, what we need to do is, okay, remove loading. It is the same type of being subjected to a unit value of redundant. So we have to label first. So this is A. Wait, what happened with my pen? Wait. Okay, so we have to have two systems because we will calculate one deflection in one system. Okay, one deflection in one system, we have to have two systems. Delta one node is a displacement in redundant in primary first, in primary beam, and we have another system called redundant system. It is F11. So F is the symbol for primary system. Primary system. Okay, wait. I need to shut down this first and shut down this one node first. I do not know what happened. Okay, let's say we open it back. Okay. So we have four position. We have four position A, B, C, and D. Okay, and here also same A, B, C, and D. Okay, we have four position A, B, C, and D. Okay, both are determinate beam. Both are cantilever beam. Both have same cutting section. Okay, so if in primary beam, okay, it is a determinate beam subjected to all external loading. It is primary beam. Okay, in redundant beam, so this one is redundant beam. This one is redundant beam. Redundant beam. Okay, this one is redundant beam. One primary beam, one redundant beam. Primary beam is a determinate beam subjected to all external loading. Redundant beam is a cantilever beam, same type of primary beam, but this time it is subjected to a unit value of redundant. Original, this is dy. This is original. Original, we put back the dy, but not as roller, but we put dy as an applied force named dy. And what happened if we change dy to 1 times dy? 1 times dy. That is why everything F dd we have to times with dy. F cannot stand alone. We have to times with redundant. Because original it is dy. We remove dy, so it become 1 times dy. So due to a unit value of redundant, the deflection is called as F. So that is why we must pair F11 or FDD times with dy. Okay, so original based on the principle of superposition, these two diagram is plus. This is principle of superposition. Okay, we have to plus these two in order to get original or actual beam condition. Okay, so a unit value, due to a unit value, we will calculate reaction at A, and due to external loading in primary beam, we will calculate reaction at A as well. So we will analyze both diagram. We will calculate reaction and write the moment equation. Write the moment equation, and after that we continue to calculate displacement. Okay. So we can start to calculate reaction right now. Okay, Okay, we can start to calculate reaction right now. So, okay, let's do it. Calculate together. Okay, the vertical force. The vertical force in primary beam. Okay, the vertical force at AY in primary beam is equal to 160, right? So this is 160. 160. You can write the answer in do you have the chat box? If you have, do you have the chat box? Okay, you can. I don't see the chat box here. Doesn't matter. Okay, please calculate. Okay, it is 160. It is 160. What about the moment? What about the moment at A? Moment at A, we have to calculate. Moment at A, we have to calculate. It is MA negative plus, we have 60 times 3. We have 60 times 3. It is plus 60 times 3. 60 times 3 and 100 plus 100 times 6 equal to 0. Okay, so MA is equal to 6. 60 times 3, 180 plus 600. So we get here is 780 kilonewton meter. Okay, this is the moment in primary frame. It is 780. This one is 780. Okay, 160 and 780. Okay, do the same, calculate reaction and moment in redundant beam. In redundant beam, so AY is negative 1. Okay, MA is 1, 2, 3, 3, 6, 9. So this is 9. Okay, so now we have already determined the moment at A and AY at support A. AX will be 0 because it is beam. Okay, no axial deformation, no axial force. Okay, now we will write moment equation. Based on these two diagrams, we will write moment equation. And moment equation for primary beam, we name as, because we will refer to this symbol. Okay, from the notation that we use in compatibility equation. In compatibility equation, we find that the label is 1 and not. 1 and not. Okay, you can also use D, but you have to constant use D. If you want to choose 1, you have to constant use 1. Okay, constant use 1. Okay, so we should have moment equation come from two systems. One is primary system, one is redundant system. So for primary system, we label the moment equation as M naught. M naught, and for redundant number 1, we label the moment equation as M1. Means that from these two diagram, one we get M naught, and another one we get M1. M0, 0, 1, 0, 1. Two redundant, we will have 0, 1, 2. Okay, now, so from this, we will write the moment equation. We put into the table the equation. We put into the table. So, in the table, we have to list members. Member, origin, limit. Okay, we have 2M, M naught, and M1. So we have 2. We have 2M, we have M naught and M1. M naught and M1. So okay, here is M naught. M naught from primary system. From primary system, it is M naught. M, small m, okay, naught, M naught. Okay, and we have M1. So one for primary, one for redundant. Okay, this is M1. This is M1. Okay, if we have two redundant, M0, M1, M2. M0, M1, M2. Okay, so we have three cutting section. We have three cutting section, 1, 2, 3. The first cutting section is for AB. Second cutting section is for BC. And the third cutting section is for CD. Okay, when we write moment equation, always choose the shortest cutting section. Always choose the shortest cutting section. So origin A will be the shortest. Okay, and origin D will be the shortest. Okay, and okay, for BC, we can choose A, we can choose B, we can choose C, we can choose D as origin. Okay, all join can be chosen as origin. Always choose the shortest cutting section. Okay, or the easiest for you. The what is comfortable, you just use it. Okay, let's say we choose A here. A. Okay, limit. Be careful with the limit. Okay, whenever origin is A for AB, means origin A means in AB, A is origin, so limit will start from 0. 0 to 3. Okay? 0 to 3. For BC, for BC, because A is origin. A is not inside B and C. A is outside BC. So it cannot start at 0. So because in writing moment equation, we have to understand one thing. Okay, we want to write moment equation at, okay, we want to write moment equation like this. Okay, this one is B. This is C. A outside B and C. And we want to write moment equation that is true between B to C only. And origin means X is equal to 0. Origin means X is equal to 0. So when X move to B, X will equal to 3. When X is moved to C, X is equal to 6. That is why the limit for for BC origin A is 3 to 6. Okay, 3 to 6. It is 3 to 6. Okay, 0 to 3. 0 to 3 because D is, okay, so it is D is origin because we choose D as origin because the condition is like this. When we have this D and C, origin is okay, like this. Okay, this is the cutting section. This one is C, this one is D. Origin means X is equal to 0. And we want to have equation that is true between C and D. Means that X here is equal to 0, X here is equal to 3. That is why in this case it is 0 to 3. So in short, when we want to write moment equation for CD, if C or D is origin, so we always have 0 to L. But for BC origin A, we cannot start the limit start from 0. Okay, we cannot start limit from 0. We must understanding this diagram. We must understand this diagram because the limit is 3 to 6. Okay. And careful with the sign convention as well. The moment of this is clockwise. Okay, the moment. So here the moment is counterclockwise. Okay, careful with the sign convention of moment as well. Okay, So now, okay, I will move the diagram first. This is X. Okay, because I need to, okay, change this size. Okay, now we want to write the equation. We want to write the equation for A, B. AB, origin A, it rotates counterclockwise. BC, it rotates counterclockwise. CD, it rotates clockwise based on the origin that we have chosen. Okay, so for the redundant, we have to follow the same. We have to follow the same. Okay, for AB, origin B, AB origin A. Okay, AB origin A is 160x minus 780. It is 160x minus 780. It is 160. It is 160x minus 780. Okay, and for D, it is equal to 0. The moment equation, origin D for CD is equal to 0. This one is equal to 0. This one is equal to 0. And for BC, what we have is, okay, now go back to this diagram. Okay, go back to this diagram. This one is 780. This one is 780 and 160. Okay, and X. Okay, X is this distance. This is X. So this one is X minus 3. This is X minus 3. So when we want to write equation, for this, it is negative M naught. It is negative M naught. Negative M naught. Negative M naught plus 160x. 160x minus 780 minus 60 x minus 3. This is equal to 0. So we simplify this. M naught equal to 160x minus 780 minus 60 plus 180. 180. Okay? 60x. So simplify this, we get 160x minus 60x. This is 100x. Minus 780 plus 180, it is minus 600. Okay? Minus 600. So it is 100x minus 600. 100x minus 600. 100x here. 100x minus 600. Okay, so we will try to write the moment equation for M1, for redundant system. For redundant system, for the first cutting section, it is 9 minus x. 9 minus x, same goes to cutting section number 2. It is also 9 minus x. So please recalculate, please recheck. It is 9 minus x. Okay, it is 9 minus x. Nine minus x. 9 minus x. Nine minus x. Okay, 9 minus x. And okay, this one, it is x. Okay, m minus 1 times x is equal to 0. It is x. So this one is x. So this one is x. So please practice to write the moment equation. Okay, please practice to write the moment equation. Okay, now we have all the moment equation. The moment equation. So what is the next step? We can substitute all this displacement into the formula. Into the formula of displacement. Okay. Into the formula of displacement, we will calculate two displacement. One is theta, one knot. Theta, it is theta, one knot. We get from compatibility equation. And we integrate two moment equation equal to 1 over EI. This is 1, this is EI. Okay, we integrate from 0 to, okay, from 0 to L. From 0 to L, it is M1, M naught. M1, M naught because we refer to the notation. This is M1, M naught. Okay. M1, M naught because we refers to this. Okay, M1, M naught. 1 and naught. Okay, so this is, we will, okay, M1, M naught dx, M1, M naught dx. Okay, and this is equal to, okay, M1. M1 is 9 minus x. 9 minus x. M1, it is 9 minus x. And time with M naught, 160x times 780. So we replace M naught. Okay, so the limit for the first cutting section is 0 to 3. 0 to 3. Okay, so we have to add another one. We have to add another one. Okay, it is the second cutting section. The second cutting section. The second cutting section. Okay, for the second cutting section, it is 9 minus x. Okay, times with 100x minus 600. 100x minus 600. Okay. Dx and limit for this one, for the second cutting section is from 0 to 3. Sorry, from 3 to 6. From 3 to 6. Because origin is still A. Okay, origin is A. Origin is A. Okay. So this is for the second cutting section. And for the third one, since M naught is equal to 0, so doesn't matter, we don't need to write. If we don't want to write also okay. So we just solve this. We just need to solve this. Okay, we just need to solve this. Okay, please solve this and tell me what is the answer. Tell me what is the answer. Okay, please calculate. Delta 1 naught. Delta 1 naught. Okay, and give me the answer. Okay, give me the answer. Okay, so we have to integrate two moment equation, M naught and M1 for the displacement in primary beam. We label as delta 1 naught. Delta 1 naught. Okay, delta 1 naught. And please calculate the answer. Okay, it is negative. Negative. Yes, 14760 over EI. That is correct. Okay, the answer is okay. Very good. The answer is negative. Negative 14760. 14760 over EI. Okay, over EI. Okay, now please calculate. Please calculate F11. Please calculate F11. 14760. 14760. Okay. M square. M1 square. So it is F11. This is F11. It is M1 or M1 square. Okay, M1 actually. m1 or m1 square. Okay, so it is 9 minus x square. 9 minus x square What happened to this? Wait. Okay, doesn't matter. It is x minus x square. I just copy and put back here. Okay, 9 minus x. And it is 9 minus x square. Because it is m1 times m1. Okay. So what is the answer? What is the answer? Okay, what is the answer? It is integration from 0 to 3. Oh, we have another one. Sorry. We have another one. We have x square, another one. We have x square, so we have to plus another one. We have to plus another one. I will copy this. Copy. So the last one, start from 0 to 3. From 0 to 3. To 3. So delete all this. Okay, I will insert this is x square and we change the position. X square is here. X square, m1, x square, and this we will find the answer for this one. Okay, this. Okay, so what should be the answer? What should be the answer? Two, 4, 3. 2, 4, 3 over EI. It is positive. It is positive. It is 2, 4, 3. 2, 4, 3 over EI. 2, 4, 3 over EI, correct. Okay, so these two are the displacement. So now we are going to substitute. Okay, we are going to substitute. Okay, delta 1 naught and F11. Delta 1 naught and F11. Okay, into the compatibility equation. Compatibility equation. Okay, so what should we get? The equation. So I copy back the equation. This is the equation. Copy. Okay, this is the equation. Okay, now we replace. We will replace. Okay, theta 1 naught, which is equal to negative 14760 over EI. It is negative. It is negative. Negative 14760 over EI, and replace F11 to 243, right? 243. So this one is 243. 243 over EI. Okay, for F11 times the dy is equal to negative 0.025. Okay, now normally when we have to calculate or analyze structure with support settlement, if settlement is given in unit mm or meter, means that we have to have E and I value. If E and I value is not given, you can also assume the E and I value. Okay, let's say, since I don't give you the EI, okay, at the beginning of the question, okay, let's say P is equal to 200 GPA. E is equal to 200 GPA. E equal to 200 GPA. Okay, and I is equal to 500 times 10 power of 6 mm4. 10 power of 6 mm4. Okay, so let's say E is 200 GPA and R is 500 times 10 power of 6 mm4. Okay, mm4 also, this one also, wait. It is mm4. mm4. So we need to check the unit first. Okay, we have to check the unit first, because we have to use 200 kilopascal, not gigapascal, and we have to use I in M4, meter 4, not mm4. Okay, so we change we change E to, okay, we change E to equal to 200 times, okay, 10 power of 6. 10 power of 6. Kilopascal is kilo Newton per meter square. Kilopascal. Okay, kilopascal is kilo Newton, is in kilo Newton per meter square. Meter square. Okay, and I meter square. And okay, we need to change to 500 times this one also, times millimeter 4. Change to meter 4 is 10 negative 12. Negative 12. Now we change this to meter 4. Meter 4. Okay, now we have changed this to meter 4. So EI is equal to 200 times 600 power of 6 times this one. Okay. And we have 12 here. We have 12. 6 plus 6, 12 minus 12. It is equal to 10 power of 0, which is equal to 1. Okay. 10 power of 0 it is equal to 1. So that is why normally we consider EI is just like this. (200) times 500 times 1 actually, because 10 power of 0 is equal to 1. Okay, so what we need to do now is to solve this. Okay, we will solve this. Solve the compatibility equation. Solve the compatibility equation. Compatibility equation. Okay, solve. Okay, we have this. This is the compatibility equation. So now what I want to do is, I don't want to divide 14760 divide by 205, 200 and 500, and 243 divide by 2 and 500, 200 and 500. But I want to bring this 2EI to the other side so that we can get 0.025 times E times I. Okay, times E times I. Okay, so we will times with 200 and 500 here. Okay, so we now remove EI. 14760, 14760, and 243. So we get this equation. Now we get this equation. So simplifying this, okay, simplifying this, what we get is dy is equal to plus with 14760 divided by 243. Wait. Copy first. Divide by 243. 243. So we have this. Divide by 243 here. 243. Okay. What is the answer? 50.45. 50.45. It is 50.45 kilonewton. Kilonewton. Okay, 50.45 kilonewton. Thank you. Okay, now out of 4 unknown reaction, 1 redundant, we have solved the redundant using compatibility equation. Now we will continue to calculate remaining reaction. And to calculate remaining reaction, we have 2 choices actually. Because the 3 remaining reaction, okay, the 3 remaining reaction, 3, we have 3. Here. Okay, I write here. Okay, we have 3 remaining reaction. These three remaining reaction, okay, if we want to solve the 3 remaining reaction using equilibrium equation, what we need to do is we just need to draw back the diagram. We have AY, we have MA here, MA 60, 100, and 50. 50.45. 3 meter, 3 meter, 3 meter. This is AY and MA. So we can analyze the 3 remaining reaction using equilibrium equation. This is by using equilibrium equation. Anyway, we actually have another choice. The easiest way. Okay, easier than this. And it is called as superposition method. We can actually determine the 3 remaining reaction either using equilibrium equation, or we can also use superposition method. It is actual beam equal to primary beam plus redundant applied. Because MA and AY we have calculated, okay, in both system, okay, we have already determined MA in primary and MA in redundant system. And we know that primary system and redundant system, it is actually come from the principle of superposition, where when we need to combine back, it is primary beam plus redundant beam. And always remember, redundant we have to times back with dy that we remove. Okay, so by looking at this diagram, so I have put plus already. Okay, I have put plus already. So if we want to calculate MA, so what we need to do is only, okay, plus this 780 plus this 780, negative 780, plus with positive 9 times with dy. Okay, use superposition method. Actual beam equal to primary beam plus redundant dy applied. So everything inside the redundant beam, we must times back with the redundant value. Okay, MA or AY in redundant beam, we have to times with 50.45. Okay, so MA is 750, negative 750 plus 9 times 50.45 for MA. And for AY, it is 160 plus negative 1 times 50.45. Okay, that is the easiest way. Easier than using equilibrium equation. Okay, so now I will continue this. Okay, the three remaining reaction will now be determined using superposition method or principle of superposition. Using the principle, so I have to move this diagram. I have to move this diagram. Okay. Principle of superposition. Okay. So MA. So it is MA. MA equal to negative 780 plus 9. 9 times 50.45. Of course, you can recheck using equilibrium equation. Please calculate, recheck using equilibrium equation. Do you get this, the same answer? Do you get the same answer? It is negative 780 because this is actually MA. This is MA in primary system. This is MA in primary system, and this 9 is MA in redundant system. Okay, please check. Okay, do you all get the same answer? Do you all get the same answer for moment at A? Okay, this one is using principle of superposition. You can also check by using equilibrium equation. Okay, 780 negative 780 plus 9 times redundant. So what is the answer? What is the answer? What is the answer? Negative 325.95, correct. Okay, it is negative 325.95 kilonewton. Okay, if you don't believe this, please recheck using equilibrium equation. Okay, now continue to calculate AY. Continue to calculate AY. Continue to calculate AY. What is AY? AY. Okay, and AY is 160. 160, right? AY in primary system is 160. And negative 1 times with 50.45. Okay, so we will get AY. Okay, we will get AY. So what is the answer? What is the answer for AY? What is the answer for AY? 109.55, correct. Okay, thank you. 109.55 is correct one. Okay, it is positive. 109. 109.55. Okay. So now we have got all four unknown reaction, and by having all these four, we can actually continue to draw shear force diagram and bending moment diagram. Okay, you can write your question if you have. Okay, in the comment section you can write the question if you have. Okay, this one I want you to continue to draw diagram. Okay, I want you to continue diagram. Please put this. Okay, I believe you write all this right on your own paper. You just have calculated all this with me, and please continue to draw diagram. Continue to draw shear force diagram and bending moment diagram. Bending moment diagram. Now I want to know how you draw the diagram. Okay, draw diagram first, and please put your notes based on this example. Please put into your folder under hand out. Okay, please put under hand out. Draw the diagram. Okay, draw the diagram. Okay, because I want to see either I need to maybe explain to you in detail how to draw the shear force diagram and the bending moment diagram. Okay, draw first. Let me see your diagram first, and after that only I will know whether I need to repeat again about drawing the shear force diagram and bending moment diagram. And anyway, I have video explaining about drawing the shear force diagram and bending moment diagram. Please find in my YouTube channel. Okay, so I hope everyone understand about this. So this is beam analysis, and beam analysis like this. Actually, we will use the same procedure, the similar analysis, the same formula. Okay, when we analyze frame. So I believe that students should be able to analyze frame when you have understand about beam analysis, because beam and frame has similar analysis except frame has vertical element. Okay, with a combination of vertical element and beam element in frame. So I want you to continue do as this, the same procedure. Choose any other question. You can choose frame as well. So please make sure before we move to truss example. Okay, please make sure that you understand very well about beam analysis and frame analysis. Okay, so for truss example tomorrow, actually you also can answer truss example, truss question, because we will use the same compatibility equation, the same procedure, except the displacement formula for truss is different. Okay, we do not write moment equation in truss, but we have to find the member forces as internal forces in truss. Okay, so the table will be different because the table will be based on the member forces, and for primary truss and for redundant truss, and we have to find the total based on the formula. So please find the formula to calculate deflection in truss, because we use the different deflection formula whenever we analyze truss. Okay, so thank you very much. I think that's all for this session. Inshallah, if I have more time, I will make another video. Okay, regarding flexibility method. Okay, I hope you continue to finish all the homework given, all the formative assessment. Okay, please do, so that I can check whether you understand or not about the flexibility method. Okay, so I use 100% English because this video is also watched by student outside Malaysia. That is why I use English. Okay, so thank you very much. Thank you very much. We will continue in the next session. So wait for my info about the next session. Thank you very much. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.